Thank you very much, Francisco. Indeed, now we're entering our ceremony for a Thesis Award. And it's an award basically to encourage all of us, particularly students in different backgrounds, one, to encourage students to do something related to conservation of migratory species, and therefore then the award creates that incentive. Even those who had not thought of picking such a topic, probably such an award will create that incentive for them to do that. But more so, once we have more and more research is being done on migratory species, it helps us also to increase our knowledge base, information, particularly the latest data on the basis of the findings of the various research which are undertaken on the subject of conservation of migratory species. And not only that, and by doing so, it's not just increasing the knowledge base, but then of course empowering those who are doing and those of us who will be reading these researches and use them in terms of building the capacity of those who are interested in the subject to be able then to know more in the subject area and to get to know the findings. As my colleague has indicated, we normally advertise for the submission of those concepts in our website and also through a specific correspondence to all focal points to help us to advertise the same in their countries, and that was done. And in response to that, we received 61 applications from 25 countries. So 61 students submitted their PhD dissertations, and this total from 25 countries. Indeed, I don't want to say all, but probably most of them, or most of the abstracts received were quite good. And I need to use this opportunity to sincerely thank those experts in the field who volunteered their time, their knowledge to help us review this thesis. We all know how lengthy PhD theses are, and to get few individuals each to read a minimum of 6 PhD theses at their own free time, I think we can't get such a better commitment than that. In many cases, we'll have to pay them dearly. Professors are paid at universities to supervise students. But here we had experts in the field who gave themselves that commitment to help us. I sincerely need to thank them. A number of them are in this room or at least attending this talk. And I'm sure those are the ones who probably have expanded their knowledge base more than many of us who could not read all of them. For the Secretariat and for the many libraries, it was good also to increase our documentation of the various subject areas related to migratory species. Because virtually 61 theses, that clearly indicates how many topics or subject areas which had been discussed. However, we had to get the reviewers, and after that, then we had to get the jury. About 14 jury who set to now review the top shortlisted, and there were 14 we began with, and it took us a whole day. At least I was privileged to be one of them. A whole day from 14 to be able to identify only one of the best, whom I will announce soon. And of course, in addition to the top best of the best, we also had to identify additional 3 best, who unfortunately the cash award will not be extended to them, but they will receive their certificates, again for additional 3 theses on migratory species, which were considered the next top best. I also need to take this opportunity, probably through the friends of the chair, I see one in front of me, or the government of Germany, to thank Museum Koning in Bonn, which provided us the facilities for the whole day for the jury to sit in a closed door to further review the shortlisted thesis to be able to come with the top dust. But all this would not have happened if it was not for the strong partnership with the Lufthansa, Germany. And we have a representative here. Sir, we thank you so much for providing us this opportunity to be able to get our students get more interested on the subject of species and do more work on that subject. I hope we can continue to count on that support. Probably the next COP will have more than one who will receive that award, but I think we should be able to entice our partner Lufthansa, Germany. Probably there might be also others to be able to encourage more students to do this thesis. So having said this, our best winner this year was a candidate who did a thesis on interaction of African elephant and African honeybee. I'm sure many of us might wonder what is the relation between such a big mammal with such a tiny bee. And that relation, which could be so important, we all know the size of the elephant. What could a bee do to an elephant to make a difference in our communities? But something was done on this, and I would not want to talk about it since the author is with us. But at least that thesis enabled us to make, or it made that unique discovery that African elephants avoid feeding on acacia trees that host beehives, be it empty or occupied by African honeybees. And the relevance of that was basically, and we will be told, that relation, why caring, and if that is the case, we also know how elephants are a threat to the local communities. The local communities which have to live in harmony with such species. And we also know the many challenges, many countries where there are elephants, the human-animal conflict. But here we have a situation probably where the animals and human will live in harmony, but we'll be told. And this was no other than Dr. Lucy King, who did that thesis, and I can welcome her in front so that we can all see her. Welcome, Lucy. So before I invite her to tell us exactly what are these discoveries she has been able to do, permit me then to announce the other three, the best of the best, who we refer them as also the Laurent under this award. And these are Dr. Franziska Tanneberg, who did a thesis on the population of aquatic warblers, habitat selection and management. The other Laurent is Grant Hapcraft for a thesis on ecological implications of food and predation risks of herbivores in the Serengeti. Not because I come from that region, but this was the choice of the jury. And the third is Dr. Christian Triveller for her work on travels to feed and feed to breed, annual circle of migratory raptors, Montagu's area in a modern world. So these are our three Laurents, and they are not with us, but of course their certificates will be sent to them. Lucy, welcome. I think we're all interested to hear what is this discovery.
Thank you very much. This is a wonderful opportunity to be here to talk to you today. And I just wanted to say thank you to the CMS Secretariat and particularly to Lufthansa for flying me here from Nairobi yesterday. It was a very long journey, but it's been worth the trip. I'd like to talk to you today about my PhD thesis, which I finished last year. It took me about 4.5 years to finish it. And the topic is using bees as an elephant deterrent. I work in Kenya in East Africa, which has a very impressive protected area network. The Kenya Wildlife Service is very active in this country, and we have a wonderful national park system. However, elephants do migrate beyond the borders of the national park, and we work up in this northern area. The green is the elephant population in Kenya, and we work in the northern, most populous area of elephants, in the Samburu-Laikipia ecosystem. And our research camp is on the borders of the Samburu and Buffalo Springs National Parks. This is our little research camp along the Nera River. It's a very, very beautiful place, and it's got a lot of elephants. The last count, there was 7,500 elephants just in Samburu-Laikipia. One of the core areas, the core point of our research in this area is to understand individual elephants. And by knowing every single one, using these identification sheets, we're able to tell exactly which elephant we're working with, and we get to learn a lot about the hierarchy issues, where the elephants move, which offspring is related to which animal. It's a very, very intense study, and it's been going on for almost 16 years now. So I was very lucky to be able to use these identification sheets during my study. Of course, the interactions of all the elephants in the reserve is a fascinating topic. And we get these amazing bull elephants like the one on the right who comes in every couple of years. We get bulls like this who come in and we don't know where they've been. We don't know where they've come from. And if we're lucky enough, we can put some satellite tracking collars on them and find out where their migratory routes are. But they really are very special when they come in, and you can see the females like them as well. So this is the core centre of our study area. This is the Samburu-Laikipia region. The dark red and dark yellow at the bottom is actually the farm areas as well as the ranching areas, and the light creamy areas at the top are the sort of pastoralist community areas, as well as the national parks and reserves, which are in the dark green. And I'm going to just show you the tracking data that Save the Elephants has managed to accomplish over the last 15 years. This is a total of about 83 tracked elephants, and you can see very clearly the black lines show that elephants are migrating all over the landscape, all the way through the different ranches, the farms, some of the conservation areas. There's a very dense area around Samburu, Buffalo Springs, but of course you can tell immediately that elephants are not confined to national parks. The red lines are the migration corridors that Save the Elephants has identified in the last 15 years. And these corridors, of course, are a real focus for local governments and the Kenya Wildlife Service to start protecting these areas. But critical to data like this is looking down at the small level. What happens to people living in these migratory corridors when you have hundreds, in fact thousands of elephants walking through your farming area? I'm just going to show you a magnificent photo of Mountain Bull. He's one of the most famous elephants in Kenya. He has a GSM GPS satellite collar around his neck, and he lives on the slopes of Mount Kenya, which is one of the most iconic, beautiful mountains in Africa, the second highest in the whole continent. His tracking data shows us a very interesting pattern. On the left-hand side, you can see a concentration of his migratory behaviour on the slopes of Mount Kenya in the Amenti forest. But on the right-hand side, you can see that he actually streaks through what you can clearly see as a farming area to get to the right-hand side of the picture, which is another protected area. Now, Mountain Bull does this route about between 11 and 14 times a year, and we've known this because we've monitored him since 2006. So you can imagine those farming communities are having a little visit by Mountain Bull pretty much every month, and he is representative of many other bull elephants. So this is incredibly important data. It really helps us understand where the elephants are moving through farming communities. And this is a typical photo looking down from the air of a group of one collared elephant. It's actually an elephant called Genghis Khan, and he is surrounded by 18 bull elephants walking through these communities. It's very, very scary for people. And although these elephants are following their natural migration patterns, there's a lot of conflict that occurs. This is just an example of the type of conflict we're talking about. Farming fences being pushed down, crops being trampled and eaten, and farmers become very, very irate. And of course, we all know the consequences. Usually it means the death of an elephant or a severely injured elephant. So I started looking at an unusual idea, the idea of bees and elephants. This is an ancient rock art image, a therianthrope rock art image from Ebusingata in southern Africa. And this is actually from the Stone Age. And we wondered if this whole folklore in Kenya of elephants being scared of bees might have actually originated from many thousands of years ago. It's really fascinating to find this rock art image. I started looking at recording bee sounds and seeing whether I could actually prove that elephants were scared of bees. It was such a crazy idea to begin with, so we started very small. This is me recording a wild beehive. We threw a stone into the middle of the beehive, and the bees erupted out of the hive into the microphone, and we managed to record a very, very angry swarm of African bees. We played this bee sound back through a wireless speaker that was hidden inside what we called a fake tree trunk. A very sort of Shenzi thing, but it looked, we fitted this into the bushes around the elephants and they couldn't see the fake tree trunk. And then for many months we simply recorded how elephants responded to the bee sounds from a video camera. And of course we played different control sounds as well to see how they reacted. Now, I hope you can see this as a little image of what the elephants look like when they're under the tree. And it's meant to be a video which isn't playing, but see, it might come on. This is the typical scene that we play bee sounds to when a family is resting under a tree and the bee sounds come from one side and we video them. Usually what happens is the elephants react very, very strongly. They put their ears up, they smell, they run away from the bee sounds. I'm afraid the video didn't work. But it was an incredible reaction, and the data was published in Current Biology, and it really was the first time that anyone had shown that elephants were scared of bees, which seems so improbable, and we wanted to take this a little bit further. The other thing we managed to do was to record, using special microphones, what the elephants were communicating about when we played bee sounds to them. And we placed these very small earthworks microphones around the base of the elephants when we played bee sounds. And we recorded how they rumbled and how they communicated to each other. We were able to show very clearly that the rate of elephant vocalizations was almost triple when they were hearing bee sounds as compared to hearing a control sound, in this case of white noise. And this tripling of vocalization suggested to us that the elephants were actually communicating about this threat in the environment. So that led to even more investigations about what exactly were these rumbles that they were communicating about, and were they special rumbles, or were they just a heightened awareness of a problem in the area. So here we have a graph showing the different strengths of the vocalization. On the left-hand side, we have a sonograph of the bee rumble that's emitted by elephants. And we're looking at the second format here of the vocalization of elephant rumble. It's very, very elevated. And we can only really show you how elevated that is when we compare it to the second format of the rumble produced when they're hearing control sounds of white noise, which are non-threatening sounds. And this was repeated time and time again on all the rumbles that we recorded from elephants. So this information can only be looked at on computer level, because the rumbles which elephants make are so deep, they're below our hearing. They're at what's almost called infrasonic level. And it was very, very interesting to discover that we had a unique rumble that was created by elephants in response to these bee sounds. So turning from the theoretical side of whether elephants are scared of bees, we really felt we had something here. We felt that we had proved that elephants were scared of bees in the sense that they would run away from them. We understood that they communicated about them. And now we wanted to see how we could adapt this to a real practical application in the field. And we went to work with this Turkana community just south of Buffalo Springs, a really fascinating tribal rural community. And we started a very long-term participatory project, working with the communities, getting them to help us understand how the elephants move through their communities, through their farms, how they crop grade. And we had different groups. This is a women's group that we talked to, and they just told us everything about the elephants, where they come, what time of day and night, how it affected their livelihoods. And it was a very, very important aspect of the project to include the community in this research. They helped us draw up a very, very detailed map of the area that we worked in. 64 farms were mapped, and we used half of them, so 34 farms were included in the study. We actually put bee-hive fences around half of the farms that we looked at, and the other half of the farms were kept with traditional thorn barriers. Now, these beehive fences, the concept really is just to use simple beehives that we can produce locally out of local material, and they're used out of, you can see, very, very cheap material, some wooden tops, some corrugated iron sheets, and some plywood, which are just nailed together, very cheap, about $25 per beehive, and all the community helped make them. And we made them in batches of 50 at a time, just to get as many beehives as we could out into the community. Of course, everyone helped put them around their farms. You know, we had 17 farmers which each had beehives around, and they loved it. It was a very participatory, it engaged them in the ownership of the beehives, and of course the women were very, very much part of that process. So this is a typical beehive fence. The beehives are 10 meters apart, and they swing very simply from 2 pieces of wire held up by a simple post. And in between the beehives, there's one simple piece of wire that connects each beehive to the next. Now, there's nothing electric about it. There's no moving parts. It's very cheap, and that's very, very important. If an elephant attempts to cross the fence, they will actually push into the wire holding the 2 beehives, and the wire will cause the 2 beehives to swing and release the bees. And it also creates a huge crashing noise as the iron sheets hit each other. It's very, very disruptive, and I've personally tested this by mistake by running into one of these wires, and the bees erupt like a volcano from out of the hives, and they sting very painfully. So I've tested it myself and know that it works. Of course, we did we went through the scientific detail of measuring the maize, making sure that one farm wasn't more attractive than the next farm without the beehive fence. We made sure that the maize crop was similar in all the test fields. And I have lots of community helpers, which is very important to help me with this. And over the months, we just watched the maize grow inside the farms with the beehive fences, and the farms without, the maize just didn't grow. And we had so many visits by elephants into this area, and the data was really, really, really important. Before I show you the actual data, I'm just going to show you how we started monitoring some of these beehive fence farms. This is the tracking data from just one elephant, a very wonderful female called Resilience. She was known to be a great migrator, and we can see here how vast her migration patterns were. But inside the dotted circle, this was my beehive fence community, and we suspected that she went into this area before we collared her. But once we'd collared her, we saw that she used this area quite frequently, and we were very worried about her because she had large tusks and she was very precious to us. Oh, back to the beginning. Excuse me, I don't know what happened there. So we monitored Resilience very closely. Sorry, I don't know why it would do that. There we are. So when we zoom into that white circle, we can see the very specific detail of her hourly tracking data around these farms. And she was joined by a female called Wendy, who is in the yellow dotted signals. Now, Resilience, at this point, because we saw she was going into the communities, we were remotely able to change her collar to 15-minute positions. So we have a 15-minute detailed position of the red elephant. And we could see her going all the way around the farms, and she didn't go into it. The yellow elephant, Wendy, is on a 1-hourly position, so we can see roughly how they went around the farms. This is very important to us to look at this sort of level of tracking data. And then right on the ground, we also used farmers. And this was a farmer who had a data sheet showing the beehive fence on the right-hand side. And this blue line he drew on of where the elephants came to the beehive fence. And you can see they attempted to go in once, twice, third, fourth, fifth, 6 times. They tried to cross the beehive fence. And these elephants were so frustrated. He's actually written on the right-hand side, standing furiously, which was his interpretation of how annoyed these elephants were. They just couldn't get into the farm. And he was somewhere hiding in one of these farms watching, so he was very brave, because this was 10 o'clock at night. And he's written at the top, the elephant feared the fence wire. So this is the wonderful sort of data we were getting back from the farmers firsthand, experiencing this type of deterrent. And very simply, this was the simple data we had from a year. The thorn barriers, the elephants just push straight through them. They're so used to walking over thorns, they basically have 0 deterrent having a thorn barrier. But the beehive fence, in all the study time, we only had one bull elephant that broke through, and we were really astonished. We were really not expecting that level of deter, and we thought we'd have a smaller number, but we had no idea that it would be that effective. Once the elephants had broken into some of the communal farms, they escaped out of the beehive fence in 6 cases, and that was when elephants were being chased directly by farmers. So the deterrent of the beehive fence didn't stop them exiting the farm, which was very important. And of course, very importantly, we also did workshops with the community, particularly with the women. I really feel that some of these small microfinance projects really are successful when you involve the women in the community. And we taught them how to harvest the honey successfully. We donated some of the beehive suits just to help them with their, to encourage them and give them courage about harvesting the beehives. And we've coined a new type of honey called elephant-friendly honey, which has a great catchy name, and it really has caught on, I'm pleased to say. Although the bees are not very friendly to the elephants, of course the elephants are now safely being able to walk around the farms and they're not being attacked by the farmers. So we feel this is a sort of elephant-friendly honey symbol of the project. And of course it's a great PR tool to give to lodges and to give to local wardens and rangers to explain about the project. And again, just emphasising the role of women in this project. The women get involved with producing the honey. They also are often one of the breadwinners in the community. Most of these women, I'm afraid, are using charcoal to bring income into their communities. And we're hoping that over time they may replace some of that charcoal income with honey income. Sugar in Kenya at the moment has quadrupled in price, so sugar is very hard to get hold of. So having a source of natural sugar, which you can also use as medicinal for children, it's very, very wonderful to have honey instead of sugar. So one of the most useful outcomes for my project, I think, this year is the production of a beehive fence construction manual, which is designed very much for local farmers, local researchers, local KWS researchers, and we're hoping that more and more people around Africa are going to start using this manual. It's very practical, it's got lots of pictures. We're hoping to translate it into Swahili. I'm not quite there yet, but at the moment it's just in English, with plenty of diagrams explaining how to build the top bars, how to keep the queen separate from the honey, so you can have pure honey, and how to record and monitor the hive occupations, so that you can record how much honey is produced from your beehive fence. It's very important that you pay back the cost of your beehive fence within a year or two of the construction costs from the sale of honey. And finally, this is a third project that I went to set up, a test site down in Save National Park, which, as I'm sure you know, is one of the largest elephant populations in East Africa. There's almost 12,000 elephants just in Save National Park. And the elephants run riot through some of the communities down there. And this is a beehive fence test site, which worked astonishingly well. You can see how high the maze is. And there are just simply beehives stopping the elephants going in. And the elephants have migrated around this farm to a water hole where they regularly go every night, and they've left the maze alone. So if you'd like to download any of the research papers or my thesis, you're very welcome to go to our 2 websites, savetheelephants.org and elephantsandbees.com. And finally, I'd just like to thank very much all my personal sponsors and donors over the years: Kenya Wildlife Service, Rufford Small Grants Foundation, ESRC, NERC, Save the Elephants, Disney has been a huge help, and the University of Oxford. So thank you very much.
Lucy, fantastic presentation. I think it's very exciting, and I want to go to Africa now immediately. Left the cops and go to the bush. Thank you for your presentation, and it's a pleasure for me to call to the podium Mr. Alex Klein-Schumacher from Lufthansa. It's the second part of this ceremony, very short, but without him this ceremony would be impossible. Please, Mr. Schumacher.
Yes, thank you very much. I will keep it really short, but a few remarks may be allowed. So, Executive Secretary, Lucy King, ladies and gentlemen, 7 years ago, On the 23rd of June in 2004, the 25th anniversary of the Convention of Migratory Species was celebrated. On that occasion, the UNEP CMS Award, Thesis Award has advertised for the first time. This had been preceded on the initiative of the then Executive Secretary of the CMS by talks with Lufthansa. That marked the birth of the Thesis Award, which was then presented to the public in Bergen. In the call for applications, it says, the Thesis Award on Migratory Species Conservation will promote scientific research and conservation of migratory species as defined by the Convention. The thesis should provide new data and insight into the biology and ecology of migratory species. Research results must be applicable to conservation measures to the benefit of migratory species, and the award is worth 10,000 euro. Here today in Bergen, the award will now be presented for the third time. On behalf of Lufthansa, I am delighted to be able to take part in the presentation of the award here in Bergen. As member of the jury, but also in our own capacity as sponsor and partner from the private sector, I heartily congratulate this year's award winner, Dr. Lucy King. I would also like to acknowledge all the other entrants who took part in this competition. All the theses submitted were of an extremely high standard and prove that throughout the world there are young, dedicated scientists whose work is devoted to conserving endangered migratory species. If this prize helps to encourage young biologists to apply themselves to this topic in future, then setting up the award has been a worthwhile exercise. For Lufthansa, the sponsorship of the award remains an expression of our long-term commitment to maintaining biodiversity. As you may know from the very outset, the crane has been Lufthansa's logo, it's the Lufthansa brand, the crane is the symbol of our company. This led us from an early stage to commit ourselves to supporting this bird, many species of which are endangered. In addition to the crane, we have expanded our long-standing nature conservation activities to other species and their natural habitats. In all these cases, however, our partners are highly competent environmental and nature conservation organizations. One important aspect of our work is to point out repeatedly that maintaining biodiversity is of crucial importance for life on our planet. We are aware of the importance, both ecological and economical, of migratory species for many countries and regions, and we see much scope for development, particularly in the sphere of sustainable tourism. Yet, despite all this progress, it's not a matter of course for representatives of commercial companies to speak at conferences and congresses hosted by environmental or nature conservation organizations. All too frequently, there are still reservations about prejudices towards industry. It is all the more important, therefore, that those concerned overcome this attitude and enter into a dialogue that will ultimately lead to cooperation. Meanwhile, on the part of the industry, there is a growing realization that it must bring its own entrepreneurial activities into compliance with the criteria of sustainability. Commercial companies have realized that they have to make a major contribution towards resolving problems. Likewise, for Lufthansa, this forms the basis for its commitment to protecting nature and the environment. For only those companies that are actively involved in environmental care and adopt measures to minimize the negative ecological impact of their business activities have the credibility to engage in environmental sponsoring. Finally, once again, I would like to congratulate the winner of the third UNEP CMS Thesis Award, Dr. Lucy King, and I wish the conference every success. Thank you. bank, that would be a check, but Lufthansa is an airline, and we regard the symbol of an airline is not only the crane, but also a ticket cover. But Lucy King can regard this as cash.